So in the second video looking at similarity, we'll be going through some of the most common and popular exam style questions that you could get asked, covering how to prove two triangles are similar and also answering questions that look like the diagrams you can see on the board. So I've found that going through exam papers that there tends to be two general questions that you get asked when you're dealing with similar triangles in exam papers. So we go through the first one. Now in this first question, depending on how and whereabouts this question lies in your exam paper, may depend on what information you get given and what it is you've actually got to find. So in the first part of this question, we've been asked to prove that triangle ABC is similar to ADE. Now usually the key thing when it comes to identifying what topic a question is, which is always the first thing you should try and do when dealing through an exam paper, is look out for keywords. Now the key thing with regards to this particular question is that it's not as obvious that this is a similar triangles question, and one of the reasons why is simply because of the fact that we haven't got two questions and the word similar is not really involved in the question. Now with regards to getting started with this particular question, and just bear with me while I mess around with this question, is first thing we need to do is prove that triangle ABC is similar to triangle ADE. Now when you're looking at this particular question, you've got to realise that you should be able to spot that you've got two triangles. Now here, if I just identify what those two triangles are, so one triangle is what I'm going to try and highlight in green, and the other triangle, let's try and go for a contrasting colour, which will go for blue, is this outside triangle. Is that there? Now from watching the previous video on introducing similar triangles, is that to show, and this is one thing that I would certainly write when you're writing down your answers. So if I just write answer, and let's use a red pen. So answer, so in terms of A, so if triangle ABC is similar to triangle ADE, then all internal angles must be the same. So although I can't prove the sides are similar, because obviously I don't know what the sides of these triangles are, I can then focus on the internal triangles. So all internal angles will be the same. So what I need to do, and what I'm also going to do, is go through what the expected notation is going to be, excuse me, just trying to get my words out there, is going to be. So it's always important to write down what proof you're going to be using. So if the two triangles are going to be similar, then the internal angles must be the same, and that's what I'm going to prove. So to start off with, what we're going to do is angle A is a shared angle. So what I mean by that is, as you can see from the two triangles of both the green and the blue triangle, is that this angle here appears in both. So therefore angle A is going to be the same for both those two. Now the next thing I'm then going to prove, so just get a different colour pen, let's go for this one. So here I can see that angle AED is going to be equal, which I'm looking at this angle here, is going to be the same as angle ABC. Again, just put little hats over that. And the reason for that is because it's a corresponding angle, as corresponding angles. Now you may know them as F angles, but the correct name and what you'd get marked for in the exam is using the correct terminology, the correct vocabulary, which is corresponding. And likewise, if I then use different colours, let's use this highlighter, I know that angle ADE is going to be equal to angle ACB, and again, as they are corresponding. So as you can see, is that you've proven, so therefore triangle ABC is similar to triangle AED. And what I've done there is I've proved and showed that the two triangles are similar. And again, by noting the fact that in all internal angles of similar shapes are going to be the same. So the next thing we then need to prove is work out the length of D and E. Now if I just quickly get rid of all of this, and just bear with me, let me just create a bit of space, and I'm sure I've got rid of something else that I shouldn't have done. Yep, got rid of that box. And so let's just get rid of all of this when it decides to work. So looking at B, which is our normal typical question that we get asked. Now obviously you don't always have to prove it. Sometimes the question might state in the question that triangle ABC is similar to triangle ADE, in which you don't need to prove it because it's told you in the question. So answering question B, what we need to make sure is that we draw the two triangles out separately. So I've got a triangle AED, and again what I'm going to try and do is making sure that the orientation of the triangles are going to be the same. So I've got the yellow angle as a double angle on D, and the orange angle which is on the left. And I've also got another triangle which is ABC, and again I'm just going to highlight those two rogue angles, and let's just colour in A just for artistic purposes. So the next thing I then need to do is write down the information that I know. Well, I know the side A to E, which is 3. I know that the A to B, now this is where a lot of students tend to go wrong and make mistakes. Now the length of A to B is, you think, oh, it's going to be 5 because that's the other side of it. But actually it's 8. And I also know that the length of B and C is also going to be 8. So, and what I'm trying to find is this angle here. So just like we did in the other video, the first thing we need to do is find the scale factor. So look at which two sides do I know the corresponding lengths of. Well, I know 8 and 3, so the scale factor is going to be 8 over 3. And then to find out what x is, I'm going to use its corresponding side on the other shape, which is 8. And because I'm going from the big shape to the small shape, I'm going to divide by my scale factor. Now if I type that into my calculator as sort of carefully as I can, using the fraction button if you've got it on your calculator, and the answer you should have should be 3, and so x equals 3 centimeters, and there we go. Now you might have found, well, obviously, because if you've got 8 and 8, then the side of that triangle is going to be 3 and 3, because you might think that this side here is going to be the same as the other side, etc. So here you can see we've got 3, and that's going to be 3, that's 8, and that's 8. That's just pure coincidence. And probably thought on mine I should have picked more other numbers. So hopefully that makes a bit of sense. But what you want to generally do is recognise that although you can only see one physical triangle, it's actually a triangle within a triangle. So draw the two triangles out separately. Make sure the triangles are drawn in the same orientation, and make sure you label carefully. And then once you've got that sorted, it then becomes a very easy similar triangles question, and it's just a case of finding the scale factor and then deciding whether to multiply or divide. So let's have a look at the second type of common question that tends to come up, which is like so. And again, if I can just scroll across, there we go. So in this case, what we're going to do is we're going to go through a proof question, and because there's no mention in the question that the two triangles are similar. We can definitely see two triangles, it's pretty obvious because we've got one connected to another. But the first thing we want to do is prove that these two. The only information that we do know is that A and B is parallel to DE. So in other words, what you might find is that these two lines might be marked, or it might tell you in the question like it does here. So just like we did before, what we've got to prove, we've got to prove that angles are the same for both those two triangles. So if I just highlight this triangle first, so that's one triangle I'm working with, and let's use another highlighter to highlight this triangle here. So these are the two triangles I've got to prove that are similar. Well, to start off with, so looking with A, in this case of, so if triangle ABC is similar to triangle CDE, all internal angles must be the same. So what I'm going to do now, so going through this, and this kind of goes into some terminology on this one, but we know that angle, and again, so I'm going to go through angle ACB with a hat above angle C, is going to be equal to angle DCE, and the reason for that is because they are opposite angles. Now going from this, so to our next angle, let's use orange this time, so I know that this angle here is going to be the same as this angle here, so angle BAC is equal to angle CED, and the reason for that is because it's the Z angle, or more better known as alternate angles. And likewise, if I look at angle ABC and CDE, that's going to be also the same because they're also alternate. So angle ABC is equal to CDE, and because they are alternate. So therefore, triangle ABC is similar to triangle CDE. And like I said, it's really important that you state what proof you're using, which is this bit here, the mathematical calculations that we're using, which is this point here, and then just to summarise, your icing on the cake is just proving what you've been asked to show or prove. So moving on to then working out what the missing lengths are. So again, to do that, what we need to do is separate the triangles, or redraw the triangles I should say, and making sure that the orientation of my diagram is going to be the same. Because with this particular question, unlike the other question where you had a triangle inside of the triangle, the orientation of the two triangles are different, as you can see in terms of the way that I've coloured in my angles. So if I start with angle, and again, let's draw this as I've got C at the top, and I've got A and B. And if I call this orange, this angle is going to be green, and this angle is going to be blue, then drawing out my second triangle, I'm going to have blue on the top, orange at the bottom, on the left, and green on the right. And so what I now need to do is label and the measurements. So I know that A to B is 4 centimetres, and I know that O to orange to green is going to be 10. And on the bigger triangle, I know that the side that links blue and orange is 6, and green and blue is 8. And the angle I've been asked to find is A to C. Now A to C is the side that's got both orange and blue, which is therefore going to be orange and blue, which is this one here. So from this, and what you can see from the triangle, so I'm going to call this one X. So from this, the first thing I need to do is find which side do I use to work out my scale factor. So again, looking at this, it's going to be using the 4 and the 10. So I'm going to do 10 over 4, which is 2.5, or you could write it as 5 over 2, which is no problems at all. And then to work out X, so the corresponding side to X is 6, so I'm going to do 6, and then because again I'm going from small to big to small, I'm going to divide by my scale factor, and so I do 6 divided by 2.5 or 5 over 2, whichever floats your boat. It should still give you the same answer. Again, answer of 7 over 2 or 3.5 centimetres as your final answer. Now again, if I decided to go row and did 6 times 2.5 or 6 times the scale factor, I get 15. And again, alarm bell should be ringing, because when I actually look at my diagrams, I can see that that's not the case, because the triangle of CDE should be bigger than the other the triangle ABC. So again, if I just label this, that's E and that's D. And so again, with this particular question, it's really useful for you to draw the triangles out. Obviously, you're not allowed to use colours in the exam, but if it's on a textbook or in an internal exam, that'd be fine. You could just relabel it, or use the double hashes or double angles that we've drawn in previous questions. Now, just want to go over the last type of question you could get asked, which I'm not going to go through any particular question on this one, is questions that look like this. Now this is very similar to question 1 that we did in this video. All it is that it's just been rotated. So it's important that you're able to spot that coming from this we've got two triangles. So I've got the large triangle, which is labelled A, B and D, and I've got a smaller triangle which is E, C and D. And if in the question or on the diagram it's giving me numbers to represent or things I want to find, you label it on this triangle, and if the side that you're trying to find, call it X, just to make your life a little bit easier, but also to relate it to some of the earlier questions that we did in the previous video.